Good day, class. This is Mr. Peasley, here to give you a small, little, and otherwise brief presentation on atomic theory. Now, to begin, we will start with a Greek philosopher named Democritus, who was around the time of 480-460 BC. Now, he basically started the whole thought process that matter consists of small, indivisible particles. These particles he called atomos. Now, these atomos, he thought, basically comprised everything that you see before you, and even the things you can't see, such as the air around you. The atmosphere itself is actually comprised of particles, believe it or not. Now, take a hop, skip, and a jump about almost 2,000 years later, and we get John Dalton in the 1800s. Now, unfortunately, no one really investigated Democritus's claim up until this point. And so now we have John Dalton kind of picking up the torch here, and he actually offers this atomic theory that, we've pretty much kept and maybe modified here and there, but otherwise it goes something like 1. Elements are composed of extremely small particles called atoms. For number 2, all atoms of an element are identical, same mass, size, and properties. However, all elements are different. Compounds are made of one element with a ratio of number of atoms as an integer. And then 4, chemical reactions act only as separation, combination, or rearrangement of atoms. There is no creation or destruction. Now, with that out of the way, let's take a few steps back here and kind of investigate a little bit deeper. So, for number 1, the elements are composed of extremely small particles. John Dalton called these atoms. You've probably heard the term before. It's basically the building block of everything, from the oxygen we breathe to the chairs you sit on. Even to yourselves and myself, we are all made up of atoms, believe it or not. As you can see in the video, you have an oxygen atom on the left as the green circle, and then a nitrogen atom as the blue circle. Each element is composed of an atom. However, these atoms differ between elements, as stated in the second theory. All atoms of an element are identical. However, all elements are different. So, do you kind of see how that works? If you have one element, everything is the same. Mass, size, properties, all the same. Now, if you move to a different element, that all changes. The mass, size, and properties are different. But if you take another atom of that same element that you just chose, then it's going to have the same mass, size, and properties. Does that make sense at all? If not, get online, go to Twitter, tweet me a message, you have the hashtags, or go to the class website, do a comment on the video. Do whatever you can. I'll answer as promptly and actively. And the example I give here on the screen, you'll see is there are 3 oxygen atoms, 3 green circles, all representing oxygen. Every single one of these, if you were to take them and analyze them, are going to have the same mass, same size, and same properties. All the time, every time, for the most part. We'll get into the little ifs, ands, and buts of the whole thing, but for now, they are exactly the same. There is nothing different other than you have 3 atoms. Now, on the right, you see we have 2 sodium atoms. The sodium atoms are identical to one another because they are the same element. They are the same mass, size, and properties. However, all elements are different, so therefore, the mass, size, and properties of the oxygen atoms, not even close to being the same as the sodium. Just, they are incomparable. Later, when I can be in class, you'll see me basically toss some sodium into some water, and I think you'll enjoy the visual effect. But moving on, and kind of giving you a little taste of hopefully what's to come, compounds are more than one element. ratio of number of atoms is an integer. So here you see we have a carbon atom, the red circle, attached to two oxygen atoms, the green circles. Now, whenever you have a reaction, basically everything forms and reacts in whole numbers. You cannot have half of an atom. You just can't. If you take half of an atom, you get a new element, basically. You get a different element. It's not the same element. And we'll basically get into, in probably the next class or two, what really makes up an atom and what distinguishes one element from another in terms of those properties. But for now, carbon dioxide, CO2, carbon plus 2 oxygen yields carbon dioxide. So that means you can't have 1.5 oxygens to produce carbon dioxide. You must have 2. Again, if you have any questions or concerns, by all means, get on Twitter. Ask a classmate. Get a hold of me. I mean, you have everything possible. Lastly, for number 4, chemical reaction is only separation, combination, or rearrangement of atoms, with no creation or destruction. So in other words, any chemical reaction we perform, can only do one of those 3 things: separation, combination, rearrangement. So basically, in the reaction I give you, you have oxygen, O2, you have 2 atoms of oxygen bonded together, basically, and you're adding H2, hydrogen, 2 atoms of hydrogen, to that oxygen. Now, what happens when you combine hydrogen with oxygen? What do you drink every day, for the most part? Water, right? Basically, at this point, you should begin to see the pattern that everything forms in exact numbers. The reason why we have 2 H2O on the right side of the arrow is basically to balance out the number of atoms and reactants placed into the reaction. So in other words, you have 2 oxygens in the product on the right side of the arrow, and you have 4 hydrogens. 2 hydrogens times 2 is 4. And again, that should equal to the left side. Now, again, we'll get into a little more depth of reactions, reactivity, what goes where, how to name it, etc. But for now, this is a brief overview. And if you have any questions or concerns, again, I invite you to get on the website, ask a classmate. And lastly, for tonight, for your homework, I would like it if you would go online and just do a basic little post of, 1, what you think of the atomic theory currently and where you are in terms of your understanding. And I'd also like you to kind of discuss and analyze and comment and give feedback to both me and your classmates about their post, and kind of just discuss the various things that we've talked about today. The video will be available online, as well as course notes, etc. So I encourage you all to go ahead and do that tonight, and I look forward to seeing all your responses. And again, remember, be courteous, be kind, and most of all, be constructive. There's no point in being rude. Thank you all. Have a good day.